In the words of the Russian hacker, welcome to my laboratory where safety is #1 priority. Right, so the whole point of this practical is we are going to make a salt from an insoluble compound called copper 2 oxide. For this experiment, you're going to need a Bunsen burner. I say get 2 heat-proof mats, you'll see why later. A tripod, a gauze, 1 mole of sulfuric acid, a 25 ml measuring cylinder, a 100 ml beaker, a spatula, your copper 2 oxide powder, stirring thing, I've forgotten what it's called. You need your filter paper, your conical flask, your funnel, your tongs, and an evaporating basin. So just stir. Now obviously, because we're handling chemicals, we need to make sure that we've got our goggles on at all time. And in terms of the procedure, I've lined it up so it's in line with the procedure. So number one, what you're going to do, and you're going to use a pipette ideally to take the sulfuric acid and add 20 ml of sulfuric acid into your measuring cylinder. Then you're going to put that into your beaker. Then you're going to put the beaker on top of your gauze and you're going to warm it up. You do not want to boil it, you just want to warm it up. Once it's warm, you turn the heat off, and then you're going to add your copper 2 oxide into it using the spatula, and you're going to make a reaction happen. And you're going to keep mixing it until you can mix, till no more will react with it, and you're still left with some copper oxide that just won't react. So it'll be a saturated reaction. After that, you're going to get your filter paper, place it in the funnel, put the funnel in the conical flask, and you're going to take your reaction, your products rather, and filter it through the funnel. And then you're going to place your filtrate, that's whatever's left in the conical flask, and put it into your evaporating dish, which is this one here. Then you're going to heat some of it off, so boil some of it off. Well, don't let it boil, but let some of it heat. Let the heat reduce its volume by about half, and then you're going to place it in the windowsill and allow crystals to form. So then you're going to allow it to evaporate and allow crystals to form. So let's go through the procedure for real. Before we go into the procedure, I want to teach you guys how to use a Bunsen burner. It's shocking how many students, they go through all their school life and they cannot use a Bunsen burner properly. So the first thing is you have this hole within the Bunsen burner. When the hole is open, you're having lots of oxygen go into the Bunsen burner, and what this means is that you're having a complete combustion reaction because there's loads of oxygen, and so you'll have a blue roaring flame. That flame is for heating. Now, when you want the flame to be visible, you close the hole. That means you're not getting enough oxygen into your Bunsen burner, so the reaction is an incomplete combustion reaction, and therefore you see an orange flame, which is evidence of carbon being burnt. Okay, so it's incomplete combustion, and this is just so that it's visible, so that you're doing it safely and you do not heat with an orange flame. So let's put the Bunsen burner on, and when you are putting the Bunsen burner on for the first time, make sure the hole is closed. So I've turned the light off for added effect, and as you can see, it's quite a tall flame. Now, this is a safety flame, this is how it should be. And now you can easily and carefully and safely handle the Bunsen burner from the bottom. Right, I can hold it, no need to be scared of it. You can move it around from the bottom, no problem. Now the other thing is because we're heating, right, when you do have it on your safety mat, and we're going to be heating that solution, which we'll come to in a bit, you're going to want it on a roaring flame, right? So you should be able to hear that, and that's why we call it a roaring flame. Now because the lights are off, we can see the flame, but if the lights are on, which they will be, you will not be able to see the flame, so that's why it's important to have the safety flame on. Now, the other thing is it's quite tall. If you want to decrease the height, which we will want to do because we don't want to boil the acid, we just want to make it warmer, you can adjust it from this part here, which is just like adjusting your cooker at home. So let me see if I can get the full shot in. So what I'm going to do, I'm going to slowly twist this to make the flame shorter. This is the problem with this one, you see. This is not very sensitive, but what you can do is you can adjust the height. Let me see if... Right, so when you're adjusting the height, it's easier and better to adjust it from a safety flame point of view. So put it on your safety flame and then twist the tap, the gas tap, so that the size of the flame decreases. So there you are. I've decreased the size of the flame. So, and we don't need a big massive flame for this one, because like I said, we're not aiming to boil. We're aiming just to warm up the acid that we're going to be using. So number one, I'm going to use the pipette to take out 20 ml of the sulfuric acid and place it in my 25 milliliters measuring cylinder using this pipette. So I've filled it up to 20 ml. I've come down to eye level just to avoid any error while filling. So I'm going to transfer this into my 100 ml beaker, which is brilliant. So I've transferred that. Make sure you get all of it in. Now what we're going to do next is we're going to heat this 100 ml beaker. We're going to warm it. Remember, we do not want to boil it, we just want to warm it up. I'm going to put my Bunsen burner on a roaring flame. Right, so the hole needs to be open. Right, and I'm going to place it underneath. Now you can adjust the height if you want to, but I'm just going to leave this for a while, just let it warm up so that the rate of reaction will happen quicker. The rate of reaction between the sulfuric acid and the copper 2 oxide that we're using. So I'm going to pause it and let this warm up for a bit. Okay, so what I did was I increased the temperature for a little bit, just to kind of speed it up, maybe 10 seconds max. I can see there's quite a bit of movement within the sulfuric acid. That gives me some indication that it's quite warm, or warmer than it was to begin with. So I'm going to use my tongs and my second safety mat, or heat-proof mat. And so that's what the second heat-proof mat was. I'm going to take my tongs, I'm going to take this off. It could be hot, I don't really want to risk it. And carefully and slowly place it onto my second heat-proof mat, which is what I've done here. Now, next what you're going to do is you're going to take a spatula of your copper 2 oxide and you're going to place it in here and mix it with your stirring rod. Right, so I've placed my copper 2 oxide into there. I'm going to stir. I'm going to keep stirring until it's fully reacted. And then I'm going to just make any observations that I notice. So what do you notice as you add it in? What happens? Just keep a note of all the type of things that you noticed. And just literally keep on adding until no more will react. And you'll know no more will react because you'll have lots of solid copper oxide left. Just keep stirring, keep stirring, keep stirring. And then keep adding until no more will react. So I'm going to add some more, but I'm not going to show this part in the video because it might take a long time. But this is the procedure pretty much you're going to keep doing. So, now once you've done that and you feel that you can't get any more to react, which is what I feel, what you're going to do is you're going to take the filter paper, put it in that funnel there. Right, so I've just used a bigger filter paper because the other one was too small. And I'll show you in picture form how to actually fold it up right at the end of the video. So now that I've got this in any case, all we're going to do now is we're going to filter our reaction, our product through here. And what we'll be left with is two things. The thing at the top, the thing that's going to be left in the filter paper is called the residue, right? Because that's what is left over. And the solution that pours down at the bottom is called the filtrate because it's been filtered through. See how clever they are and how they do name some things using some sense. So I'm going to pour the product in, I'm going to filter it through. This process is called filtration. This is something that you should have actually done and learnt about in year 8. particularly the residue bit, which is going to be left at the top, and the filtrate bit, which you can see is being drip by drip going down into our conical flask. Don't overflood it, guys, don't overflood it, just be patient. Patience is a virtue, that's what they say. And so just keep going until you've got your residue at the top and your filtrate at the bottom. Right, so once you've got your product out, what you're going to do is you're going to transfer it to the evaporating basin. Right. So your practical booklet says that you can evaporate half of whatever you've done and leave the other half. Well, I don't really have that much, so I'm just going to leave it as it is. And what you're going to do is you're going to place it on the windowsill, leave it over a couple of days and see what forms after a while. So there'll be an evaporation happening and you will be left with crystal salts. Okay, so let's look at the theory behind this now. What's actually happened? What we've done here is we've taken our sulfuric acid and reacted it with our copper oxide. Because these are the two things that are reacting together, we call these two reactants. So our reactants was sulfuric acid and copper oxide. Now what you need to know about copper oxide is that it is insoluble. Okay, so we've taken an insoluble oxide, reacted it with an acid to make our salt, which is copper sulfate plus water, which is why perhaps the method suggests that you evaporate some of it off, so you evaporate more water, so you could potentially have a change in the crystal formation. Interesting hypothesis that I have is what would happen if we do boil some of the water from the solution versus doing as I did, which was just leave it on the side and seeing what happens. Perhaps you can team up with somebody else and one of you can kind of evaporate or boil a little bit of the water out and the other one can do as I did and just leave it and just see what happens in terms of crystal formation. Now, here is the formula. It's H2SO4, which is copper sulfate plus your copper oxide, CuO, which is going to make your copper sulfate plus water. Now, I'm going to cover a tutorial on how to figure out each part of this equation, but that's for another time. So, I hope you found this video useful. Goodbye.